Welcome to Ask and Learn.
In this problem, we wish to determine the enthalpy change of oxygen for two cases of specified temperature changes. Now we assume that at specified conditions, oxygen behaves as an ideal gas. And the constant pressure specific heat of oxygen room temperature, Cp, is equal to 0.918. This is kilojoules per kg Kelvin. So we get this from our tables. So using the specific heat at constant pressure, we have the enthalpy change delta H is equal to Cp delta T. And this is equal to 0.918 kilojoule per kg Kelvin times a change in temperature of 250 Kelvin minus 150 Kelvin. And hence we get change in enthalpy of 91.8 kilojoules per kg. Now, if we use the same room temperature specific heat value, the enthalpy change will be the same for the second case. However, remember that the variation of specific heat varies with temperature, and if we use the specific heat values from our tables, then we get that Cp is equal to 0.964 kilojoules per kg Kelvin, and this is at 200 degrees Celsius and is equal to 0.934 kilojoule per kg Kelvin at 100 degrees Celsius. So we can see this value varies. So therefore, we have delta H1, which is Cp delta T1, and this is equal to 0.964. We'll suppress the units here, into change in temperature of 250 minus 150. And so we get the enthalpy change using Cp at 200 degrees Celsius to be 96.4 kilojoules per kg. Now, the enthalpy change from 0 to 100 degrees Celsius, delta H2, is Cp delta T2. And so this is our value for Cp at 100 degrees Celsius, which is 0.934 kilojoules per kg Kelvin. Again, we'll suppress the units into a temperature change of 100 minus 0. And this is equal to enthalpy change of 93.4 kilojoules per kg. So we can see that the two results differ from each other by about 3%. They are not the same. And the pressure has no influence on the enthalpy of an ideal gas.